we will understand this method of differences. This is a very powerful method that is used in summation of series. To understand this, let us take some random numbers. I have taken -4, 3, 1, 8 and 2. These are purely random numbers. What I will do now, I will take difference of these numbers. 3 minus -4 is 7, 1 minus 3 is -2, 8 minus 1 is 7, 2 minus 8 is -6. I will continue taking the differences. -2 minus 7 is -9, 7 minus -2 is 9, -6 minus 7 is -13. Subsequently, we can keep on continuing. Right, we will take just differences between two consecutive terms. Now, if we observe this minus this is this. That means -4 plus 7 is this. This plus this is this. This plus this is this. Similarly, this plus this is this. This plus this is this. Right. So now 3 is related to -4 and 7. Right. And 1 is related to 3 and -2. 1 we can write it as 3 plus -2. But 3 again we can express in terms of -4 and 7. 3 we can express in terms of -4 and 7. Now 1 we can express as 3 and -2, and -2 again we can express in terms of 7 and -9. Right. So essentially 1 we can express in terms of this -4, 7 and -9. Similarly, 8 we can express in terms of 1 and 7. 1 we can express in terms of these 3. 7 we can express in terms of this and this. This again we can express in terms of this and this. This we can express in terms of this. Essentially, what does that mean? 8 we can express in terms of these 4. Right. Similarly, 2 we should be able to express in terms of these 5. That is the idea. Right. This part, these differences, the first differences, right, this is important for us. Now the general term, how does it behave? So let's call it T1, T2, T3, T4, T5. Okay, now we have realized that 8 we can express in terms of this first line. 1 also we can express in terms of this line. So there must be a general relation. Right, general relation, obviously we can easily prove this also using mathematical induction. The general relation is let's say for example we want to find out this 4, this 8, which is the T4th term, right, which we can write it as T3 plus 1. T3 plus 1 or T4 should be equals to 3C0 into this, 3C1 into this, plus 3C2 into this, plus 3C3 into this. Right, 3C0 into -4, 3C1 into 7, 3C2 into -9, 3C3 into 18. Right. So if you calculate this, 3C0, this is anyway 1 into -4, 3 into 7, and again 3 into -9, plus 1 into 18. This comes out to be, if you do the calculation, this comes up to be 8, which is what this 8 is about. Right. Similarly, what is this 2? T2 is T5. So T5 is nothing but T4 plus 1. So 4C0 into this, 4C1 into this, 4C2 into this, 4C3 into this, 4C4 into this. That is what we have done. T5, 4C0, 4C1, 4C2, 4C3, 4C4. Right. So if you simplify all of this, what we have got? We have got this equals to 2. Right. Now we have taken some random numbers, and this is working something similar to binomial theorem. Right. We have taken some random numbers, and then the differences, because all the differences are related, right? This is obviously related on this. This also related on this. All of, right? So we are able to express this one in terms of this. Right? This time, instead of random numbers, we will pick numbers that follow a certain pattern. For example, I have chosen this kind of pattern, n square plus 3n. If substitute n equals to 1, you will get 4, n equals to 2, 10, then 18, n equals to 4, 28, so on. Right. When this, now if we try to do the method of try to do the differences, we will get 6, 8, 10, 12, 14. Right. If we again do the differences, now we are getting constant numbers. So whenever whenever you are able to express this first line, the first set of numbers, using any polynomial kind of expression, right? Then after a certain point, the differences will become constant. So for example, this polynomial is of degree 2, so that's why in the second level the differences have become constant. For example, if the first row, if it was plain AP, for example 2, 5, 8, 11, whatever, then this number, this tn or tn plus 1 is nothing but a plus n minus 1 into d, right? The general term is in the form of a linear polynomial, linear expression, right, of first degree, right? A plus n minus 1 into d is nothing but sometimes n plus some constant, right? A n plus b kind of expression, right? Now let us say if this common term or if tn is given by some expression which is of degree 3, then what is happening? For example, I have taken some random expression, n cube plus 2n square minus n equals to 1 it is 2, n equals to 2 it is 14, so on so forth, right? Now I am trying to find the difference. Now first level of difference, second level of third difference, and third level of difference. At the third level of difference, the difference has become constant. Why this is happening? Because the tn is actually of degree 3. When it is of degree 3, the third level difference is constant. When it is of degree 2, the second level difference is constant. When it is of degree 1, the first level degree is constant, right? So now this is fine. Now if we realized, if we are given the polynomial that is generating this first row, right, this set of numbers, right, then we realized based on the degree of the polynomial, the differences will become constant after third level or second level and whatsoever. Now what if we were given the numbers? Let's say we were given the numbers like this, 2, 14, 42, whatever. Then how do we retrieve this expression? That is the question. Here what will we do? To get this expression, we already decided that T4 is T3 plus 1, which is 3C0 into this, 3C1 into 2, this, 3C2 into this, 3C3 into this, right? Okay, now let's say Tn plus 1. We will try to write the general expression for Tn plus 1. Instead of writing for T3 or T4, we will directly write for Tn plus 1. Tn plus 1 is NC0 into the first, this one, NC1 into this, NC2 into this, NC3 into this, NC4, we are skipping NC4 because anyway subsequently we would have got zeros, right? So NC4, NC5 and all is not needed, right? So NC0, NC1, NC2, NC3 till NC3 only is needed, right? We will just expand. NC0 is 1, 1 into 2, NC1 is n into 12, NC2 we can write, we can expand and write. Similarly NC3 we can expand and write. If you are able to do this, then we are getting this expression, right? N cube plus 5n square plus 6n plus 12. We are getting this expression, but this expression is not equal to our original expression, right? Obviously it will not be equal because our original expression is for Tn and what we have derived is for Tn plus 1. So if in this expression, if we replace n with n plus 1, we will get Tn plus 1 expression, or vice versa. In this expression, in the expression of Tn plus 1, if we replace n with n minus 1, we should get Tn expression. Let's do that also. So let's do that. This is the original Tn expression. Let us replace n with n plus 1. Then we should get Tn plus 1, which is what we wanted to check. And yes, we got this expression, right? N cube plus 5n square plus 6n plus 2. Okay, this is actually 2, not 12. Okay, now similarly Tn plus 1 expression. Okay, Tn plus 1 expression. In this expression, we replace n with n minus 1. Right, we replace n with n minus 1, n with n minus 1, n with n minus 1, and then we simplify. We will expand and simplify. Right, n minus 1 whole cube, a cube minus 3a square b plus 3ab square minus b cube, and a minus b whole square, a square minus 2ab plus b square, and so on. If you simplify this, if you gather all the terms and simplify, we are getting this n cube plus 2n square minus n, which is our original generating function, n cube plus 2n square minus 1. So that is it about method of differences. Okay, so any random numbers, if you take, it is working, but this is very powerful when the numbers, they follow a certain pattern, right? This will be very much useful in summation of series, and because a lot of times we get numbers which are different, which are not exactly in arithmetic progression, but they have a certain pattern. How do you identify that pattern? And based on method of differences, so the numbers, probably the generating function could be a cubic polynomial or a quadratic polynomial, etc. So in this way we can figure out what exactly is the generating function.